The images you see here were taken with my phone through the eyepiece of my night vision astronomy setup. In this video, I'm going to show you details of that night vision astronomy setup and how you can get and see stunning images like this through your telescope. Hello everyone. I've had a few requests now to show the astronomy setups that I use to do my night vision live observing and photographs. So I thought I'd actually make a slightly extended video going through in a bit more, in some detail about how that is. And as a starting point, I'm going to give the example here, which is 130mm refractor, quite a fast refractor, f5, which is generally, I find that the faster optics are more appropriate for night vision. It allows more light to go in. And in this particular situation, you can see it's a standard setup with a mount, ALTAS mount, go to, and set up in visual mode with a diagonal and an eyepiece. But the eyepiece in this situation is actually a night vision unit. It's an RVMC housing with a standard night vision white phosphor tube installed in it, and you can see there that it's attached directly to the diagonal. Now this is the first sort of mode for night vision observing. It's called prime, and it's where actually you remove the objective from the night vision housing, the 1x magnification objective, and effectively just use the telescope as the objective. And you can see there in this situation, I'll give a close-up in a moment. You can see that it's actually put directly into the diagonal with no objective. And if we do that close-up, now for this particular telescope, I've actually put it in a very fast mode. So I've actually added a reducer. You can just about see that where the diagonal goes in, there's a reducer that it slots into, and again I'll show that in a bit more detail. That's actually a 0.75 times astrophysics telecompressor reducer, photo visual, so it can be used for visual use, and that takes the speed of the telescope down to about f3.7. So it gives a very fast, for a refractor, very fast sort of mode. And this is actually, helps in terms of, particularly in prime mode, where you really want, it's quite challenging on refractors to get down to a fast mode. So this is running about f3.7. And you can see here we've got the, it uses up quite a lot of back focus, so I've actually had to screw the night vision unit straight into the T2 houses straight into the diagonal. Now the night vision unit effectively in this mode acts as about a 26mm eyepiece. So for this 130mm refractor operating at f3.7, that gives about 19x magnification. So generally night vision, because you're aiming to get as fast as possible in mode, particularly for viewing emission nebulae, you generally find the magnifications are relatively low. You keep that there. If you increase the magnification, and we see various ways, to do that, particularly with the focal, that will actually sort of increase the sort of less light getting in, increase the scintillation, and actually make for less attractive viewing, generally, in my opinion. Now, prime mode is, because it's limited, it sort of minimises the glass, actually you get the sharpest stars and the more sort of pure sort of visual experience. You lose, to some extent, the amount of brightness you can get. So for very faint objects, if the Afocal mode that I'm going to speak about is potentially more appropriate, but as I say, this does give very sharp, nice sort of stars and a sort of a more pure experience, and it's generally the mode that I use now. Now, on the end of the, a couple of things about the diagonal. Firstly, in prime mode, because the night vision unit requires quite a lot of in focus, and the reducer requires even more in focus. I want to minimise the light path as much as possible. So in this situation, I've used a 1.25 prism diagonal, which minimised the light path, and as I screwed the night vision unit in there to minimise it even further. And even then, I just about come to focus with this telescope. The other thing is that generally there's sort of two types of filters used for night vision, which I generally screw into the end of the diagonal, the barrel of the diagonal, to sort of optimise the light path. So the first one, for the most common, is a narrowband hydrogen alpha filter, generally used for photographic but works exceptionally well for night vision. You want to use quite a narrow band. My preferred one is actually 3 nm, sort of almost the narrowest you can get. But you can, some people do prefer 6 or 7 or even 12 nm. It's just a bit of experimentation there. So that's for emission nebulae, and night vision is actually, that's where it really does shine. And the other part for sort of other objects such as globular clusters and galaxies. Depends on your light pollution. For sort of quite a light polluted area, Baltimore 8 or Baltimore 9, you'd use it's just a Barda 685 IR pass filter. So that effectively takes, it's not perfect, but it does sort of darken the background, take away quite a bit of the impact of the light pollution, and helps you sort of get more contrast views. When you go to better, darker sites, so Baltimore 5 or 6, you might use an astronomic 642, which allows the hydrogen alpha to come through as well. So some Orion's nebula looks particularly fantastic through a 642 at a dark site. But also it sort of increases the contrast there. And then at a very dark side, once you get to Baltimore 4, Baltimore 3, you might actually use a sort of an astronomic L3, which is actually an IR cut, because then at a darker site you tend to get the impact, you actually get an negative impact from the IR light pollution. It's just implicit in the skies, even at dark skies. So you actually want to try and cut that out and just focus on where sort of below about sort of 700 nm in the light path, and actually sort of just filter out anything above that, which is where the dark side, where you get the worst sort of IR pollution. So this is prime setup, and as I say, it's operating at f3.7 and given about 18 times. So for some of the sort of like the rosette, this would be give some excellent views of nebulae like the rosette, and some of the bigger nebulae. So I've now switched to afocal mode with this 130mm refractor, and immediately you can see that we're with a lot longer eyepiece stack, and it is ergonomically it's quite a disadvantage. And if you're actually in the night sky, you need to I find I need to tilt the diagonal to actually be able to get my eye to see through the top of it. Now, this is actually the key difference here is that you are using an eyepiece, a normal eyepiece. In this case, this is a Teleview 55mm Plossl with actually their 67mm extender, so it actually turns it into a 67mm eyepiece. I'll go into the reason why that's helpful for afocal night vision. And then we keep the 1x objective lens in place in the night vision unit, so you can see that that's in place there. And effectively then there's a Teleview TNVC afocal adapter, which effectively sort of attaches to the top of the Teleview eyepiece, and then it's got some threads in the top which you can then effectively thread in to the 1x objective here. Now, the reason this is quite a popular method, firstly, sort of standard PVS 14 units, which are often used for night vision astronomy. Generally, you can't immediately remove the 1x objective. They're meant to stay in place. So this is actually a sort of off-the-shelf solution that Teleview developed for that, where you just take the standard PVS 14, add it to one of their eyepieces with their adapter, and away you go. So that's one point there. But I mean, for my use, what it is it actually acts as a sort of a mega reducer. So in this case, effectively, the telescope, remember, has got that initial reducer in at 3.7, and then we are effectively do the ratio, so that the reduction of the 67mm is effectively the 26mm night vision focal length divided by 67, and it's about 0.4 as a reducer, so it's a very significant reducer. And in this situation, it would turn the f3.7 into a f1.4. So you actually end up with a very fast setup. The situation is with this though is that you, with that fast setup, you also get a wider field of view, a smaller magnification. So with this 67mm eyepiece in the focal mode, you actually get a magnification of just 7 times. So approximately 5 degree field of view. How I work out that 5 degree field of view broadly is basically that the standard night vision unit has a 40 degree field of view at 1 times. With 7 times, you effectively just divide 40 by 7 and that gets about hopefully about 5 times field of view. So the advantage of a focal for me, as I say, because there's more glass involved, the stars tend to be more distorted at the edge particularly, and less, particularly at the edge, less sharp. Actually, the centre stars are really quite nice, but also because you get that more light coming in because of a faster effective focal ratio, you get effectively more light going to the intensifier, night vision intensifier, and therefore brighter view. So this is actually very good for things like sort of very dim nebulae. If I really want to look at a faint nebulae, this focal is really the one there for that one. But the disadvantage, I say, if you get that lower magnification, so it tends to help with a focal. If you want to use a focal and get more magnification, generally to use bigger telescopes, basically higher aperture, and I quite enjoy using the afocal method with my 16-inch Dobsonian, and that would give about sort of 30 times magnification in this sort of setup, still with a fast setup of less than f2. So the other sort of thing with a focal is it's flexible, so you can use different eyepieces. You don't have to use a 67mm, you use a 40mm or even a 26mm, and so you can adjust magnification. As I mentioned, the disadvantage of that is as you effectively increase the magnification, you get an effective slower system, and it means less light gets intensified, so you get more scintillation. So that there is sort of, you have to sort of experiment with what suits you there. And with the prime setup, how you sort of change the magnification is effectively using reducers to increase the magnification, decrease the magnification and get a higher, brighter views, or indeed I sometimes use extenders to actually increase the magnification and get dimmer views, but more, I can see detail more easily on things like galaxies. So that's the sort of seeing both setups, prime and afocal, in my 130mm refractor. So now I'm going to look into do some close-ups of the actual setups, night vision setups. So here we've got the couple of NV units set up in the 2 different ways. So on the bottom we've got the NV unit set up in prime. You can see there effectively the front objective has been replaced just with a 1.25 inch nose piece, and that can just be effectively just slotted in as soon as you've got enough in focus to a setup, and acts exactly like a normal 1.25 26mm eyepiece. And then you've got above it the significantly longer stack with the Teleview 55/67mm eyepiece. The 1x objective of the unit remains in place and is screwed in using that adapter, and you can see that you get that longer stack. And in fact, you actually do need, this is actually the opposite in terms you get a lot of out focus. So this acts like a 67mm eyepiece, but you get a lot of out focus, and often you find that you need to use an extension tube like this one, so you actually get even longer stack to be used with the eyepiece. So that's the typical sort of setups that you'd use with a telescope. So I thought I'd finish up this video showing some of the handheld setups that I use without a telescope. So this first one is effectively a binocular. I've used a bridge, the top contraption you see, linking the two RVMC night vision units, locks them securely, and effectively then you can use them as a standard sort of binocular. Now this is 1x magnification, so you can use it very well terrestrially, but also for scanning the skies with a 1x with a 40-degree field of view. You get some amazing views of things like Barnard's Loop, the Angelfish Nebulae, and the whole Cygnus sort of nebulosity that goes through. So it's quite fun and obviously very portable. You put some, you just sort of screw in some filters to the top of the eyepiece, which I'll show in a second. Here I'm just going to show you. I've got a 1x eyepiece, and it literally just, there's some threads in there, and I've got a special adapter from RAF camera that you can order that effectively converts the thread for the 1.25 filter into the appropriate thread to go into the objective lens for the NV unit. One thing I'd say is actually for these RVMs Cs, it's actually a C-mount thread, and I can actually unscrew this, and you can actually see the thread that it takes. As I say, these are actually called NVIS objective units, and they're actually quite difficult to source. They're not made new anymore, so they just got discontinued over a decade ago. But they effectively are broadly equivalent to the standard objective lens you get in the PVS 14, but obviously they allow you to easily unscrew them, and you can you have actually a very sort of small distance then between the intensifier and the flange of that. With the PVS 14, you can actually remove the inner retaining ring. I've done it for a number of my PVS 14s, which allows you to remove the objective and lens and go into prime mode. The difficulty is you've still got quite a distance between the flange and the night vision tube sensor. So it means that some telescopes struggle to get into focus. So this is at 1x. I mean, the C-mount have got some nice flexibilities to increase the magnification beyond that. I'll give you another example in a moment. These images were taken through this 1x system. Here is Barnard's Loop, and here is the area of Cygnus with the extended nebulosity shown. So with this one, I've actually taken off the 1x objectives from the units and replaced them with 50mm f1.3, so very fast objectives, and these are like CCTV. This is actually a computer lens, and that gives about 2 times magnification, about 20 degrees field of view. And actually, that's fantastic for scanning, and there really is quite a difference, although only going from 1 times to 2 times. That change in magnification and field of view really does sort of change the perspective, and it's really something that as an additional handheld unit, I've been really enjoying. Just give that little bit of extra magnification. In terms of the filters, again, I've got some step up rings, and you can just effectively just screw them in to the front, and that can be a hydrogen alpha, or you do it both. Obviously you have 2 filters, but you hydrogen alpha or a light IR cut pass, depending what you are. But I mean, the difference 2 eyes makes for night vision, I would say, is actually even more significant than sort of normal binoculars. It really does allow your eyes to take away or sort of filter out any sort of the noise levels, and that's really helpful. Actually, that's one thing I would say as well. All these units I use are manual gain, which means you can adjust the brightness, and effectively, if there's too much scintillation, you can actually turn the gain down a bit to actually to adjust to taste in terms of this. One thing I'd say as well, these are f1.3. The typical PVS 14 and indeed the NV lens, I said, are actually slightly faster at f1.2, and so that, as you can see, that's significantly faster than the setups generally for telescopes. You actually get these wide field views, but with fantastic sort of brightness there. So it really is something to jump outside for 5 minutes or 10 minutes. Even from my in my light polluted back garden, or even better at a dark site, it just gives an amazing sense of the sky, and is one of the joys of night vision astronomy, to actually have that range where you do the telescope part for the higher magnifications and the sort of the individual objects, and you can do the handheld scanning for just getting a great context of the wider skies. So that's it. I hope that was a helpful introduction to the sort of setups I use and how I approach them. Obviously very happy to answer any questions in the comments, and if there's any particular more detailed videos you'd like me to look into, please let me know. Thank you very much.